Hi everyone. This video is meant to help you figure out how to do titration calculations. So I will go through a couple examples. For the second example, I would like you to try working a little bit ahead. So I'll ask you to pause the video and try to do the step that was previously explained. Don't worry too much if you can't do it. Try to struggle through it a little bit. It will just help you understand it better if you do, and especially if you make some mistakes and then they get corrected and you understand what happened, that will be a very valuable learning experience. But anyway, let's get right into it. So, with titrations are basically it's a way to figure out an unknown, either a concentration or how much of a solution you need to use to neutralize another solution. So, they involve acid-base reactions, and titration is just a procedure to figure out whatever the unknown is, whether it's the concentration or the amount of liters you have to use, or milliliters, the volume you need to use to neutralize a base with an acid or an acid with a base. So here's an example. How many milliliters of 3.0 molar HI are needed to neutralize 30.0 milliliters of 2.5 molar LiOH? So it's useful to first identify your acids and bases. So HI, because it begins with hydroiodic acid, it begins with hydrogen, it's an acid. And then LiOH, uh, any anything that ends in a hydroxide ion or OH negative ion is a base. So LiOH, lithium hydroxide, is a base. All right. Now, the first step, what you want to do is, before you do any calculations, is to make sure that you have a balanced equation. And from previous lessons, you should remember that when an acid and a base react, they will form salt and water. So your job is to first predict those products. What will the salt be? What will the water be? Right? But basically, the way you do it is you take, because it's a double replacement reaction, you take the first two ions, the positive hydrogen ion, the positive lithium ion, and trade places. So put lithium in place of hydrogen and hydrogen in place of lithium. So the way that's going to work is lithium will combine with iodine and form lithium iodide, and hydrogen and hydroxide will combine and form water. All right. The way you do this is you have to figure out what the charges of each ion are. In this case, they're all one. Hydrogen is +1, iodide is -1, and then lithium is +1, and hydroxide is -1. So whenever you have hydrogen and hydroxide combined, so H and OH combined, that will always form water. And then lithium and iodine, because they're both, well, lithium is +1 and iodine is -1, iodide is -1, they will form a salt that has a formula of LiI, and there won't be any subscripts because it's a 1-to-1 ratio of ions. All right. Um, the second step is to identify the variables, and the formula we're going to use for this is Ma times Va over mol A equals Mb times Vb over mol B. So basically what these are is Ma is molarity of the acid. So you will recognize that because it will be it will have a unit of capital M, which is molar, so 3.0 molar, and then it's an acid HI. So the molarity of the acid is 3.0 molar, right? Volume will either be milliliters or liters, so that's how you know the volume, right? But you have to be careful about figuring out what's the volume of the acid and what's the volume of the base. And in this case, we're told neutralize 30.0 milliliters of 2.5 molar LiOH. So actually, 30 milliliters is on the volume of the base, which means the volume of the acid is what we need to find out. Plus, another clue is that how many milliliters of that acid do we need, right? So we need the volume of the acid. That's the unknown. So I put a question mark there. And then finally, moles acid is just mole A is moles of the acid, which is basically the coefficient from the equation. And since all coefficients are 1, all of them are 1 mole HL plus a 1 mole LiOH gives you 1 mole LiI plus 1 mole water, right? So it's all ones. So moles acid is 1 mole. It won't always be 1, but in this case it is. And then on the base side, the molarity of the base, that's the 2.5 m because it's LiOH, the base, so 2.5 molar. The volume is given as 30 milliliters. And finally, since LiOH here in the equation doesn't have any coefficients, that means you have 1 mole of it. Okay, let's keep going. Now, step 3. So in step 3, you want to plug the variables into the equation. So the equation is up here again. So molarity of acid times volume of acid divided by moles of acid equals molarity of the base times volume of the base divided by moles of the base, right? So everything's given in the problem but the unknown. And finally, the equation gives you the moles of acid and base, and you will see those on the left side. You just got to be careful that you identify the acid and base properly. Begins with a hydrogen, it's an acid. Begins with ends in hydroxide or OH, it's a base. Okay, so let's take a look. So I'm just plugging in, right? Taking my variables from this side. So I got 3.0 molar times volume's the unknown, dividing by 1 mole. And finally, I got 2.5 molar of the base times 30 milliliters of it, because that's right here, divided by 1 mole, right? Then the next step would be solve for VA. I like to extrapolate and isolate the unknown variable, VA. It's a good skill to have. If you ever take college math or physics or chemistry, it's just going to be a useful skill to have. So basically, that's how VA would look isolated. I can actually maybe go back one slide. Actually, not, I guess. But anyway, that's what that would look like. And once you have that, if you're not comfortable with this, you can, of course, plug in and solve for VA as your X. But this is what you should have in the end. And that would give you 25 milliliters. So this is just basic algebra that you should be able to do on your own. So the answer then would be 25 milliliters of 3.0 molar HI are needed to neutralize 30 milliliters of 2.5 molar LiOH. And one thing you want to always do is check if it makes sense. So let's see. Acid has a higher concentration than the base, which means there are more moles of acid per liter of the acid than there are of base, of the hydroxide ion in the base per liter of that. Which means it makes sense if the ratio of ions is 1 to 1, right? Ratio of hydrogen to hydroxide is 1 to 1 from this equation. That would mean that um, acid that's highly concentrated, you wouldn't need as high of a volume that you have of the base to actually titrate that or to neutralize that, which makes sense for that number to be slightly lower at 25. Anyway, let's look at a second example. So for this one, I'm going to ask you to pause when prompted and try to do it on a separate sheet of paper yourself. So here we go. How many milliliters of 2.0 molar CaOH2 are required to neutralize 50 milliliters of a 2.0 molar solution of HBr? So actually think about, I'll give you about 5 seconds, think about which one's the acid, which one's the base. Okay, so if you have CaOH2 as your base, then you're right. And then the acid is HBr. Again, a quick reminder, if it begins with a hydrogen, it's an acid. If it ends in a hydroxide, it's a base. All right, so step 1, write a balanced equation. And remember, it's going to be the acid plus the base will make salt and water. So go ahead and do that. Pause the video and do that. I'm going to keep going. Hopefully you pause the video and try to do it. And here's what the answer should be. So of course you write HBr, the acid, plus CaOH2, the base, and that will give you CaBr2 plus H2O, water, right? So The thing about CaBr2 calcium is 2 positive. You should look it up on your ion sheet. And bromine is -1, which means that we'll require 2 bromines to cancel out the positive 2 of calcium. That's why it's CaBr2, right? And then, of course, after that, you need to balance the equation. And you balance it by, since you have 2 bromines here, right, you're going to need to put a 2 in front here to account for that. And what that does, it doubles the hydrogen, but because you have 2 hydroxides, that actually does require 2 hydrogens to completely neutralize both of the hydroxides, which means you will form 2 molecules of water from that. So hopefully you were able to get that. Next, um, identify the variables. So use the formula MAVA over mole A equals MBVB over mole B. So please pause the video and see if you can use your equation and of course the words of the problem to figure all that out. So hopefully you paused and figured that out. So here's what you should have, right? So because CaOH2 is a base, the base's molarity is 2.0, so that goes here. Of course, they're both 2.0, so that's a safe bet that you're going to be correct if you write 2.0 molar by each. But the 50 milliliters of volume, in this case, apply to the acid because it says 50 milliliters of a 2.0 molar solution of HBr, and HBr is the acid. So, of course, the acid side, the volume is known, but it asks you for how many milliliters of 2.0 molar CaOH2 are required. So it's asking you for milliliters or volume of the base. So that's our unknown that you're going to solve for. And then finally, here, the ratio of moles is not 1 to 1, it's 2 to 1, because if you look at the equation, the acid, HBr, has a 2 in front of it. So that's 2 moles of acid. But CaOH2 remains, that there's no coefficient, which means it's only 1 mole of it that's available there. All right, step 3. So pause the video and try step 3. So plug the variables into the formula given here. So do that now. All right, so hopefully you did that and you got this. So, of course, you just take them straight from your kind of inventory, right? 2.0 molar times 50 milliliters for your acid divided by 2 moles of acid equals 2.0 molar of the base right here. Volume's the unknown, so I'm putting VB. You can put VB or X in there, whatever you want. And of course, it's 1 mole because the coefficient in front of the base is 1. Right? Okay, next, see if you can isolate for VB. If you can't, then just solve for VB in whatever way you can using algebra that you know. But pause and do it now. Okay, hopefully you paused and got 25 milliliters as your final answer. If you did, then you're good to go. But isolate it all the way, it should look like this. So now it's really important to check your answers, see if it makes logical sense. So let's take a look. Both of them have the same concentration, but it requires twice as many moles of acid to neutralize 1 mole of the base, which means that if the volume of the base will be half as much, right? Because if I need two times the moles of acid to neutralize the base, and if I have 50 milliliters of the acid, then I will need 2 times fewer moles of the base, which is 25 milliliters. So that actually does make sense. And that would be all. So hopefully you work on the practice and ask me questions if you have them. You can definitely just message me if you have any questions. But other than that, you should be good to go. So good luck and have fun with this.